to record this hour because there's been some things come up that we need to make sure we have a brand new, fresh video. So first of all, we're going to be doing rational inequalities. But before we do that, it really confused, this lesson in the past has confused people. So I've added in some examples so that you actually know what you're doing, less confusing. So let's look here. This literally says, when is this quadratic less than or equal to 0? Do you guys see how that reads? So I have a graph here, a picture of the graph. So how we answer this is intervals for x, for which the function is below 0 on our y-axis. So isn't it true that it's below, here's the y-axis, true? Well, it is below 0 on the y-axis from here to here. Isn't that everywhere it's below 0? All right, so now our answer would be below 0 for the y-axis. Now we answer for intervals for x. You see what I'm saying? That is where the function's below 0 for y, true? All of our y values here are below 0. All right, so now from there, we answer as intervals for x. So we need to know from this x to this x, that's our answer, for which the quadratic is below 0. So how do we find our x-intercepts? Solve by factoring. Won't that be the easiest? Let's see if it factors. Well, multiplies to be -10 and adds up to be 9. 1 times 10, -1. We have to long factor, drop, and break. 2x squared minus x plus 10x minus 5, factoring by grouping. Pulling out an x, left is 2x minus 1. Pulling out a 5, left is 2x minus 1. So pull out a 2x minus 1, and left is x plus 5. So our x-intercepts are x equals 1/2 and x equals -5. So right here is -5, and right here is a half. So our answer is, on the interval for x, for which our function is below 0, it's from x value of -5 to the x value of 1/2. Now the question we have to ask ourselves is, do we put brackets, which means including our answers, or do we put parentheses, which means not including? Now in this one, it says it can equal 0. At -5, isn't that where y is 0? So it gets included because of the or equal to sign. So that's a bracket. And then same with the 1/2. So that's your answer. -5 to 1/2 is your final answer. Yes. Not equal to 0, right? Because then we can't equal 0. And right here it is 0. So then we put a parenthesis. So if we didn't have that little equal to sign right there, you'd put a parenthesis. All right. So now here's how we could have done this without having a graph, okay? So this is going to make sense for when we do rationals. What we could have done, paying attention, is instead we could have just drawn basically our x-axis here. So I could have made just like down here a little x-axis right here. Here's my x-axis, because that's really what mattered here. And then what did I put in? My zeros. So my critical values I'm going to put on this like number line were 1/2 and -5. So -5 and 1/2. You guys see how I'm literally just drawing this right here? It makes sense. Then from there, what you could do is just use some algebra to see if it's a true statement in this interval. So let's, for example, plug in to our original function a value below -5. Like let's plug in x equals maybe -6. So then that's 2 times -6 squared plus 9 times -6 minus 5. Is that less than or equal to 0? So if you do your calculations here, that comes out to be a positive number. Is a positive number less than or equal to 0? No. So we would have said, no, this is not in our answer set. Does that make sense? Which makes sense. Wasn't this a no on this interval? Does that, everyone see how this is working? Then let's plug in a value here. X equals 0. I always plug in if I can. So I'm going to plug in 0 between -5 and 1/2. If I plug in 0, I get -5. Is that less than or equal to 0? Yes. Okay, great. And then if I would have plugged in x equals, I don't know, 1, it would have been a positive number. Is that less than or equal to 0? No. So then we could have seen our answer right here. It was a no, it was a yes in this interval, and a no. So our answer was from -5 to 1/2. That's where our yeses were. Does everyone see how we got the same answer? That's how we're going to do it, because we're not going to want a graph. Now, we're not doing quadratic inequalities. We're doing rational inequalities. So we're in the unit of rationals, okay? So I was just showing you with an easier example. So let me just explain. You don't need to write any of this down. I'm going to give you a visual representation of what we're doing first so that we can make sense of it. So if I said to you, when is x over 4 minus x less than 3, If we kept it like this, we would be looking at 3. Does everyone see? Below 3. It is way easier instead to look at 0. So what we're going to do every time is we're going to get it in terms of 0. So I went ahead and did some algebra. I subtracted 3, and now it's less than 0. Now, we don't know how to graph a rational unless we only have one rational. We learned all our rules last time, which having one rational is going to be easiest. So I went ahead and took the liberty of putting a 1 down here and getting a common denominator. So I times by 4 minus x to the bottom and top here. Does everyone see? Here's my work. So then I've taken the top, because the next step is to combine like terms in the numerator. I've done x, and then I've distributed -3, giving me -12, and then plus 3x. So combine like terms, my new numerator is 4x minus 12, and that was all over the common denominator of 4 minus x. So, So now, what we're going to do is graph this, so we have a visual representation. So let's review where this graph comes from. So first of all, my vertical asymptote comes from the denominator, true? So I have a vertical asymptote at where the denominator would be 0. So I have a vertical asymptote at x equals 4. Now my horizontal asymptote comes from the degree on top and bottom. If they are the same, which they are both degree 1 on top and bottom, you divide your leading coefficients, which is 4, divided by -1, which is -4. So there's my horizontal asymptote. Then I went ahead and graphed it by plotting xy points. I chose to make the xy points, the easy one was the x-intercept, which is comes from the numerator, so it was at 3. Everyone good? So there's my x-intercept. Boom, I've graphed it. All right, so now let's look here. We're now looking for when is this rational less than 0. So remember, right here we're looking down, right? Everybody down. Does everyone see? So for what intervals of x is it below this value? Well, isn't all of this, all of this, all of this up to there below 0? So that was -infinity up to 3. Okay, good. Now isn't all of this right here below 0? Yes, so then from this vertical asymptote, which is 4, we then went to infinity. Does everyone see how to answer it? So here's the thing. Once again, we better check, should we have parentheses or brackets? Now think about this, right here. This is less than 0. Now, first of all, isn't a vertical asymptote an x value? We are never. A vertical asymptote we can never be, true? So no matter what, on the 4, since it's a vertical asymptote, that has to be a parenthesis. It can't include that value. Then on the 3, right here, our 0, the question is, from the top, is it equal to 0 or not equal to 0 in this problem? Not equal to 0. So right here, we have to not include that 0. So that's why I put a parenthesis. Does everyone make sense if we were to solve these by graphing? The problem is, do you want to have to graph 10 million more rationals? No, it's our least favorite thing to do, let's be honest. So instead, what we're going to do is we're going to create once again, a representation, like just an X line here. We're going to create a visual representation like we did with the quadratic. So let me just show you how to solve this by line here. We're creating a visual representation. What were our critical values for the rational? Since these are x values, we're answering for x. What are our critical values? X-intercepts, and vertical asymptotes, right? Those have to do with our x values, right? Those are the critical values for x. So let's go look at here. What are my 2 critical values? Where is my vertical asymptote? 4, so I'm going to put 4 somewhere. Okay, great. And then what is my 0? 3. So I've created now a visual representation of my x-axis right here. All right, so now let's test values. Let's go plug in a value less than 3, like x equals 0. I'm going to plug it in right here. So wouldn't that be, let's do this, 4 times -3, isn't that -12 on top? Divided by 4, which is -3. Is -3 less than 0? Yes. So on this interval, we got a yes. Does everyone see how that works? All right, let's now test a value between 3 and 4. Like, I don't know, x equals 3.5. Okay, let's plug in 3.5. So then that would be 4 times what? 3.5, so that would be 4 times 0.5, true? Which is, so we have 2 on top, and then on bottom we have 4 minus 3.5, so then times by 0.5. Do I need the exact value? No. Is that going to be less than 0? A positive and a positive is not less than 0. So then we'd say, no, that wasn't a true statement. So then when we plug in x equals 5, for example, that would be 4 times 2, right? 8 on top, and on bottom we would have -1, which is a -8. Is that less than 0? Yes. So now look, this is your answer. Our answer was yes from -infinity up to 3, true. Then it was yes from 4 to infinity. Do you guys see how we can just do it by a visual representation of our x-axis? Now the question is, from here you have a lot to think about. Was the 3 a parenthesis or a bracket? Well, the 3 was a 0, true? Was it equal to 0? Could it be equal to 0 in this problem? No, so that would be a parenthesis on our 3. On 4, can we ever be a vertical asymptote? No, so no matter what, vertical asymptotes get parentheses. Does that kind of help? Okay, we'll do a couple more examples. So that's how we'll answer it. We'll instead use our visual representation. No questions then? Okay, these are the steps I personally take if you want to take a picture. These are the steps I take to solve a rational inequality. Instead of graphing it, I'm just going to use some algebra. The first thing I do is always get it in terms of 0. It's going to be much easier to solve these. So I always get it in terms of 0. If I have to do some algebra, I'll do that. Then second, once you have one rational set up in terms of 0, meaning less than or equal to 0, greater than or equal to 0, then we're going to go ahead and factor it and then find our restrictions and our zeros. We decided that our restrictions, which come from the denominator, and our zeros, which come from the numerator, were our critical values for our rational inequalities, since we're answering for intervals of x. Then third, we're going to create a visual representation of our x-axis. We're creating a number line for x, and you'll input your critical values, which were your restrictions and zeros. Then fourth, test values for x on each interval, just like we just did. Plug it in, see if it's a true statement. If so, then yes, that was part of your domain. Does that make sense? And then we'll just go. Now, you're going to see a lot of times our answers will bounce between yes, no, yes, no, yes, no. However, we cannot assume that that always happens. What happens is students will see that happening so many times that they'll assume it always happens, and it really doesn't always happen. There are many examples, even last hour, we were coming upon where it didn't bounce. So we can never just assume that. Do you get what I'm saying? It's not always going to be yes, no, yes, or no, yes, no. Not necessarily. So we're just going to always test. Okay, here we go. So here's my first example. If you want to take notes, I think that would probably be good for this first one. We're actually going to be done with the lesson pretty quick because we do the same thing every time. So the first thing I would do is get it in terms of 0. So I'm going to go ahead and I'm going to bring this to this side using algebra. So now I have x plus 1 minus x plus 5 over x plus 2. I just subtracted that to the other side. And so we still have now is greater than 0. Make sure you stop me and ask any questions if you end up having them today. So now to do a rational, we would rather look at one rational than try to figure out this big thing. So we know all our rules, but it only works with one rational. So let's go ahead and make this one rational by getting a common denominator. So I'm going to go put parentheses around 2 terms. It's probably smart. And let's go ahead and get a common denominator. So this one needs x plus 2. This one needs an x plus 2. And now what I'm doing is I'm going to combine my terms in the numerator. So that means I must distribute. That's x squared. Then I have plus 2x. Then I have plus x. Then I have plus 2. Then I have a negative sign, so I've got to distribute my negative, minus x minus 5. So in our numerator, let's combine all our terms. We end up with our numerator as x squared plus 2x. And then it looks like minus 3. And that was all over the common denominator of x plus 2. We want to know when is that rational function greater than 0. So now we're going to go ahead and factor it so that we can easily get our critical values. So from here, let's factor the top. We'll multiply to be -3 and adds up to be 2. 1 times 3, -1. The top quick factors to be x minus 1 and x plus 3 all over x plus 2. When is that greater than 0? All right, so now we're able to go ahead and create our number line here for our x-axis essentially and put in our critical values. So I have a critical value from the denominator, our restrictions. So -2. is a critical value. Does everyone see where I got that? Now let's go ahead and put a yes or no, like a parenthesis or bracket on this right here, right now. Can we ever be a critical value? I mean, sorry, a denominator restriction. No, so that's gonna have a parenthesis in our final answer. Okay, great, let's go to our numerators and put in our zeros. So we have a critical value of 1, and then we have a critical value of -3. Now in this one, there are gonna be parentheses or brackets based on whether we can be 0 or not. So this one is not including 0. These are the zeros, so both of these are going to end up with parentheses as well. If you put those in at the beginning, usually it helps you not mess up. All right, so now let's figure out which intervals are yes, which intervals are no. So now what we're going to do is we're going to go plug in a value right here. So something less than -3, like x equals -4. So now guys, all we have to really think about, we don't need an exact calculation, is because we're looking at 0, all we need to know is it positive or negative. So plug in -4 right here. What do we get? A negative, true? Okay, a negative. And then we're going to be timesing that too. If I plug in -4, won't that be another negative right here? So another negative, and then divided by a negative. So on top, we actually had a positive divided by a negative, correct? Which is negative. Is a negative greater than 0? Is a negative number greater than 0? So right, no. That is not part of our solution set. Okay, let's go plug in a value between -3 and -2, like x equals -2.5. Okay, if I plug in -2.5, that's a negative. If I plug in -2.5, isn't that a positive? Then on bottom, if I plug in -2.5, I get a negative. A negative on top times a positive is a negative on top. A negative divided by a negative is a positive. Is a positive greater than 0? So yes goes here. Great, we're doing great. We're almost there. So now let's plug in a value between -2 and 1. So x equals 0. If I plug in 0, I'm going to have negative positive divided by positive, which is negative. Is a negative greater than 0? No. Okay, awesome. Then x equals, this is a 1, let's plug in 2. So I'm going to have a negative, a positive. Nope, I had a positive, didn't I? If I plug in 2. Positive, 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 which is positive. Is a positive greater than 0? Yes. All right, there's your answers, guys. Let's now just put that in interval notation. Where did you say yes? From -3 to -2. Do those get parentheses? Both do. Union. Where else said yes? From 1 to infinity. And there's your answer. Now, if you were to graph this, you would see that this really happened. But I'm not going to graph it. Yes. Please do the union so that I don't have to mark you off a half a point. Great question. All right, awesome. Let's do another example. The nice thing is they all work out this way. Like, that's what you do every time. Yep, I sure will. How to separate the A from the low A when you're all competing for valedictorian. Shouldn't the person that put the union get it, or the person that didn't? Probably. Okay. Like if your GPAs are the same because I don't care what you do, then you're going to both get valedictorian, which doesn't make sense. Yes. I know. You're just doing the one page. It's just I accidentally put 2 together when I sent it to the copy. Okay, here we go. Let's do this one. So the first thing you're going to do is get it set equal to 0. So we have 6 over x plus 2. Then we're going to go ahead and add this over. So plus 3 over x minus 7. We want to know when is that less than or equal to 0. Now from here, we're going to throw in some parentheses. We're going to make this one rational easier to do the thinking here. And let's get a common denominator. So x plus 2, x plus 2. This one needs an x minus 7. X minus 7. Now we're going to take our numerator and we're going to go ahead and do some math here. That's 6x minus 42. And it's a plus 3, so that's plus 3x plus 6. Because I'm distributing here. Combining like terms, that looks like it's 9x minus 36. And that's all over the common denominator of x plus 2 and x minus 7. When is that less than or equal to 0. So now we're going to go ahead and rewrite this in its factor form so that it's easy to see our critical values. Pull out a 9 on top, left is x minus 4. On bottom, we have x plus 2, x minus 7. And then we have is less than or equal to 0. Okay, awesome. Let's go ahead and make our number line now. Here we go. Critical values are at -2 and 7 and 4, right? So -2 and 7 and 4. So the next one would be 4 and the next one would be 7. All right, let's hurry and figure out if those are parentheses or brackets while we're at it. No, always, because those are restrictions, so those always get parentheses. So right here gets a parenthesis, right here gets a parenthesis. The 0 on top depends on if it's equal to 0 or not. It is, therefore when we do get 4, we are going to use a bracket. Okay, here we go. Let's test some values. So let's plug in a value less than -2, like x equals -3. Once again, what matters is the signs. So let's look here. On top, we're going to have a negative. On bottom, we're going to have a negative and a negative, which is a positive. So a negative divided by a positive is a negative. Is a negative less than or equal to 0? Yes. Am I confusing people by doing that way? Okay, so yes, great. All right, let's plug in a value like x equals 0. So that would be a negative on top. Then on bottom, we would have a negative, which is positive. Is a positive less than or equal to 0? No. True? Okay, let's plug in a value between 4 and 7, like 5. So on top, we're going to have a positive. On bottom, we're going to have a positive and a negative, which is a negative. So a positive divided by a negative is a negative. Is that less than or equal to 0? Yes. And then we're going to plug in maybe x equals 8. So then, when we plug in 8, we get positive, 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 don't we? Positives are not less than 0. So it's no. Okay, so here we go. Yeses are where your answers are. So from negative infinity up to -2, bracket or parenthesis, union, the other yes was from 4 to 7. 4 gets a bracket, 7 gets a parenthesis. Not too shabby, yes? Right. Yes, we're going to do one. So yes, so notice they've always bounced, right? They've bounced so far in our examples. That happens a lot of times, but not every time. All right. I came up with this example because I believe in my heart, but I'm not 1,000,000% sure, but I'm 99% sure this one doesn't end up bouncing between, so let's just go through it quick. So I already have it less than or equal to 0, true? Okay, so then we'll go ahead and make our number line real quick, and we'll put in our critical values. Now we restrict before we divide, that's a critical value. It's just a whole, but still a critical value. So we have a critical value at -3, then at -1, then at 1. Then our critical values come from the top two, -3 and 1. All right, we've already listed them. All right, so I believe we'll see if this one doesn't bounce. Okay, so here we go. Let's plug in, oh wait, these are no, right? Parentheses around all of them. Parenthesis, parenthesis, parenthesis. Okay. All right, so then right here, let's plug in x equals -4. Let's see what happens here. A -4 plus 3 is a negative. Then we have times by a negative on top, don't we? Divided by, on bottom, a negative, times by a negative, times by a negative. So on top, we actually end up with a positive. On bottom, we end up with a negative, which is negative. A negative, is that less than 0? Yes. Okay, yes. Okay. Now let's do x equals -2. Okay, so if we plug in, I'm going to change colors. It starts to blend together. So plugging in -2, we get a positive. Then you guys tell me so I don't have to keep looking up. Positive times a negative. On bottom, I have a positive times by a. Okay, so on top, that would be negative. On bottom, that would be a positive, which is negative. Is that less than 0? We just got yes again. Okay, let's go on. Let's changing one more time to a different color so it doesn't blend. X equals 0. Okay, let's plug in 0. You guys tell me once again. Positive, negative. So then that's a negative and a negative, which is positive. Is a positive less than 0? No. Okay, right here, testing x equals 2. So is a positive less than 0? No. Okay, so our answer was yes, yes. Okay, we do have to stop here, right? We have to jump over this. So our answer would be, in this example, from, where can I write it? Up here, right here, from negative infinity up to negative 3 parentheses, union, then from negative 3 to negative 1. Yes. But then, what about this bad boy? So how would you tell it if you did? I thought the same thing for a minute. You know, I was like, oh, I'll just connect all the way through. But then we do need to jump over this, right? So that's how we take care of it. Oh, that would have been easier. Wouldn't that have been even easier? Everyone, wouldn't it have been easier to go ding, ding, and then ding, ding, and then plug it in like that? Way easier. Yes, that would have been way easier. We did it the hard way. Bless our heart. Yes. Yep, so let's pretend this one was yes. We just do another union and add that in there. Great question. Okay, we're almost done. This is actually my last example if you guys don't need any more. Yes. So first of all, restrictions are always parentheses because those are x values you can never be, right? So parentheses means never, not me, right? Then on top, it depends, like these are the zeros. So if it can be 0, like equal to, then we've got to include our zeros. But if there's not an equal to sign, zeros aren't included, so parentheses. Good question. Okay, looking at this one, guys, it says state the domain of the function. This is actually doing what we just did exactly. The only thing is you might not realize it right off the beginning. So here's what you have to remember. Domain is, everyone just remember, what is this? What is domain? Domain is x values, true? Or input. We have to remember what domain means. X values input. Now, isn't it true that we cannot input into the real, on a real number line, we cannot input a negative number into an even root? So wouldn't it be true to say our domain is going to be anything on the underneath of a radical, which is in this case x minus 3 over x plus 3, no matter what is under a radical, which is this, has to be greater than or equal to 0. And now solve, which is what we just did, right? We just found domain in all of our other examples, didn't we? Yes, so now what would we do? We would create a number line. Let's finish this one off for the video. It'll be pretty quick. What are my critical values? Negative 3 and 3. And then we'll test. So plug in, let's just do plug in here. Let's plug in 0. So if we plug in 0, we get a negative. Is a negative greater than or equal to 0? No. Okay, so then let's plug in negative 4. On top is a negative, on bottom is a negative, which is a positive. Is a positive greater than 0? Yes. Yes, if we plug in 4, we get positive, positive. So is a positive greater than 0? Yes. Awesome. So our answer would be from, hey, but careful, let's actually check. Bracket or parenthesis? Parenthesis, because that's our restriction. This is a bracket because it's a 0 and it's including. Okay, great. So our answer is from negative infinity up to negative 3, parenthesis, union, bracket, 3 to infinity. That is your domain if that's your x values. True? There's your domain. The exact same thing, right? The only difference is you had to set up the inequality based on your knowledge of square root. Awesome, yes. Yeah, so underneath, if you were to ever graph a square root, isn't it true that when you graph square roots, you're not going to have negative, like there's not imaginaries, true? So imaginaries come from when we have negatives underneath. So isn't it true to say we're only going to be able to have positives under square root? Positive numbers. So what's under our square root here? X minus 3 over x plus 3. Whatever that is has to be greater than or equal to 0. True? Does that make sense? Great question. I'm glad you asked again. Okay, awesome. So just like my true statement, we're not going to go through it. What's the true statement? Domain, x over x plus 2 has to be, and then you just go for it. Same thing. Okay, awesome. Good job today, everyone. So 2-6 is back page is a repeat of the front page. I accidentally put 2 together when I sent it down to the copy. Lady, so it's 1 page. So you can probably finish most of that in class today. Check your answers with my keys.